Hello and welcome to my seminar about prototyping games. Let's get started. A little bit about me. I'm a game developer, production manager, and artist. My career in software began in 2014 when I founded the studio LabCat Games. Spent a few years developing my first project, KITE, which is a wild little twin-stick action RPG. Launched it on Steam in 2017, and then ended up working at a little startup called Glimmer Technology that produced augmented reality experiences and VR apps and training software. Lately, been focusing on finishing school, but I'm still working on some exciting solo projects. Just wanted to share some background so that you can better understand my perspective on the topic. You can hear some of my pixel art and some of the augmented reality products that I worked on at the startup. So what is a prototype? Well, there's a lot of gray area when it comes to the phases of software development, but it's certain that a prototype comes before an alpha. This can lead to some confusion because typically investors and stakeholders are fixated on getting a prototype, even though they want something with playability and polish of an alpha or higher. Prototype's really meant for testing purposes and often internal only. It's supposed to demonstrate core concepts only and be comprised entirely of placeholder assets that won't make it to the final build. So it's not a product demo that you would show off at events or pitch with. I've got an example here of one of the first Tetris prototypes. Of course, it's in English as opposed to Russian, but you can see just how simple it is. It's an ASCII display, and that is all that you needed to show that it was a really compelling design idea and would be fun and addicting. So why do we prototype? If everything's going to be replaced, why not just skip the stage and start full production? Well, the main reason is that it's just extremely costly to begin full production without doing due diligence prep, and it would be wasteful. With a prototype, you can efficiently try and fail over and over until it is compelling and fun to play. It's especially necessary when developing games because they have the troublesome requirement of actually being fun. A prototype is a purpose-built communication device that asks and answers questions. An additional bonus for game dev is that a prototype is where you're most likely to turn a basic game idea into something novel and unique due to the potential evolution that comes with rapid iteration. You can see this awesome little prototype here, which happens to be one of the most famous games ever, Space Invaders. And in this case, it's also on prototype hardware, which is a little bit of an old school idea, but was another reason that it used to be extra necessary to come out with a nice prototype before going into full production. So let's break down how a prototype is described. There's four main dimensions that it's evaluated along, and those are representation, precision, interactivity, and evolution. Representation is basically the delivery method. Are we interacting on a tabletop with pen and paper, or maybe it's played on a website? Or is it just a standalone EXE, the classic? Precision relates to how close to the final product it is. Maybe it's a whole vertical slice game loop where you can play through and finish part of the game. Or maybe it's just a single menu showing off how players transition between screens. Interactivity describes how functional and usable its elements are. Perhaps there's only a couple of actual mechanics that are implemented and playable, or maybe all the mechanics and features are there, but without final assets. The more the players are asked to imagine something is working and use, creative ways of pretending mock-ups are actually real, the less interactive it is. Finally, evolution is the intended life cycle of the program. Ideally, a prototype is crafted with iteration in mind, but in some cases it could be a one-off that will be scrapped after it answers the necessary questions. Like, can we build a game where every pixel is a physics object? Well, one of the first things you'd want to do there is just determine if that's even feasible with modern hardware and engineering. Now, the last two, interactivity and evolution, are definitely the most important to prototyping. You can have, something like you see in a lot of these screenshots with very low effort art assets, no sound, no music, and still have a really powerful prototype that answers all the questions you need. So representation and precision are a little bit less important than the second two. So games versus software. What's the difference when it comes to prototyping? Well, first of all, there's more similarities than differences. Almost everything in this lecture could be applied to prototyping an app or a tool as well. But for sure the biggest difference is, again, that games must be fun. Additionally, though, the game industry is even more volatile and suffers from fickle fans, fickle media coverage, and for any games attempting to ride the bleeding edge of technology, hardware evolution and adoption struggles. Now, it's worth mentioning that with gamification becoming more popular, software and tools are starting to fold in game design philosophies, which will create even more overlap between the two and more opportunity for game designers to work across both fields. Last but not least, they just don't pay the same. Working as a game developer will rarely garner the same wage as a similar job doing straight software. It's not because one requires less skill or effort. It's simply that game development is less profitable, and employers can get away with paying less because game devs would rather work on games than more standard fare. This is a cool little example of a prototype of Mario 2, which was originally a completely different game, Doki Doki Panic, that they took and reskinned and slightly tweaked. So just a reminder that prototypes can really start with nothing, or they can start with a whole game and still be a prototype. Now, another thing that I just want to reiterate is that playing games must provide value to the user. And that's one way to sort of reiterate to another way of saying where the fun is that there has to be value. And it's a more generic way of describing that sort of X factor of a game. But again, games are art, and the value in them is going to be subjective. Now, it's been said that games are the highest form of art, which is definitely debatable, but at the very least, they're the most complex form. And they can take on an infinite number of shapes and styles, and new genres are being invented every decade. All these variables mean that determining success is extremely difficult and requires more testing and feedback than general software. Here's a great example of some prototype assets for the game Demon's Souls, which would eventually become the Dark Souls franchise. And you can just see how, it's flat texture, very little detail on these models, but they're going to do exactly what they need to for the prototyping phase. So how is it made? Well, just like any software, you need time, you need money, and you need skill. Those are the three pillars that it's all built on. Now, design and engineering must synchronize to produce any software. It always takes longer than everybody thinks, especially with games where aesthetics and the look and feel is such an important factor. The art and the sound, though, they should be at a bare minimum because we're trying to be as minimal as possible with the prototype. And we want to spend as little time as we can on assets that we're going to replace. And we really need to stress that in order to prototype effectively, a secure runway must be, a generous runway must be secured. Developers can't be stressing about a deadline during the prototyping phase or something will be missed. We'll talk more about that later. So when it comes to the money side, remember, concepts are cheap. So they're a great asset to pump out. Jot down ideas, get different designs from other people, experiment, brainstorm. That's some of the cheapest work you can do, so do it a lot. Engineering, on the other hand, is expensive and time consuming. Definitely the main bottleneck. So you want to come to your engineers with well thought out plans, even for the prototype. And if you have good engineers, do show them that you love them and take care of them, because they are going to be the key to getting through this phase efficiently. Placeholder and concept art is also cheap, so generate it, but there's no reason to overproduce huge depth of content or anything like that. Just get what you need, put it in, see how it works, and go from there. On the skill side, there's a lot of great engineers out there, so don't become over-reliant on one single person. Build in redundancy. Make sure that there's documentation. They're going to go on rabbit holes trying to implement your requests, and so make sure that you know where they've gone, how they've gone there, and that they can share that with others. Now, a consistent vision through this phase is one of the most important things, because it's going to be difficult not to have it fractured with all the fun, creative ideas everybody has. So design really needs to be a stable position that steers the ship with strong communication skills. You can see here a really neat little window into the Halo prototype that started out as, maybe a dinosaur hunting game, and wasn't even planned to be a multiplayer game. And so you can just see how early ideas will morph and possibly evolve into something even more interesting by the end of it. So how do we prepare for this exciting phase? Well, first and foremost, write things down. Concept doc is the best place to start. Get your game ideas organized, and don't ever hesitate to jot down what you're thinking. It has never once hindered a process. So what do you want to include in the concept doc? Well, obviously the high overarching game concept, the genre, the gameplay description, features, mechanics, setting, story, your target audience, the hardware you plan for it to be on, a rough schedule, market and risk analysis, team requirements. All the standard things you'd want to do before you start a project are still going to be an asset here. Now, can you start with less than that? Certainly. The very basic, most minimal thing you need is the high concept and a gameplay description to begin prototyping. Keep the number of mechanics for your gameplay description small, and you should be able to summarize what you want in just a couple of lines for your high concept. User stories are a really good way to lay out your vision. They're really quick and easy to write or rewrite. And one thing that's great about them is that you can get multiple people in the team to generate user stories and then compile them together into one that everyone can agree on. And it's one of the best ways to get everybody on the same page. Now, when you're describing the gameplay, you probably want to describe the gameplay loop, which at its core is just a sequence of problems that are enjoyable to solve. And that's going to be what drives the player to stay engaged. So establish a plan for what order the player is going to progress in, what screens might be repeated, how everything concludes, and just that basic loop. You want it to be at least somewhat fleshed out. Here's a really cool example of a game that looks like a prototype but isn't. It's called Super Hot, and it uses flat textures, low polys, and you can totally imagine somebody starting this as a prototype and realizing that they found the fun immediately and didn't need to go any further on polish and excessive production, and created an incredibly fun game with very minimal assets. It follows the classic, mechanic of it only proceeds, the game only proceeds as you interact with it. So with each step you take, the game takes a step with you. And it really puts you right into the action, but also makes you feel like someone with superpowers in the Matrix. And it's just incredibly compelling concept that required almost no additional development after what looks a lot like just a simple prototype. Now, when you're building the prototype, you want to work with team strengths. You don't want to fight against them by bringing in new tools, new languages, new IDEs. It's a good idea to tap into the proficiencies that already exist. So don't double up on learning things while also prototyping. You can interview team members, try to understand where their heads are at. People always perform best when faced with a tough but surmountable challenge that taps into their passion. Even if the final product is planned to be written in a different language or format, prototyping should be done in the most comfortable environment for the team. With all the excitement that comes with prototyping, someone will need to be saying no to a lot of stuff. And so it's important to limit the scope in every way possible. And that means meetings especially should follow an agenda, and any suggestions should be formulated outside of the meeting time and brought to it already well thought out. Otherwise it becomes impossible to avoid wasteful, just long group sessions that, nobody likes a meeting that drags on, and that is the most classic situation when it comes to the prototyping phase. Now, another thing to keep in mind is the size of your team. There's strengths and weaknesses to large and small teams. A large team can iterate, share, and evolve extremely quickly. You have more people providing feedback, you have more horsepower for production, and grabbing assets that you need real quick, trying out new things. More power means faster evolution. On the other hand, a small team can execute more precisely and maintain consistency across the prototype so that there's nothing that distracts from that laser vision of what the game should be, and it's a way to execute on a simpler idea in just the cleanest way possible. So always keep in mind the size of your team and focus your prototype accordingly. Here's a really cool little prototype for someone who wanted to put Doom onto the ZX Spectrum, which is an old console, and you can see here that they were able to use those really simple old vector graphics to effectively show off a Doom clone. And it's quite fascinating, to see that the assets themselves, the polish, the resolution is really independent of the excitement of the game. So let's get into the do's and then we'll do the don'ts. When it comes to prototyping, like I've said before, you want to minimize the scope. You should be able to define your game in 1 to 2 sentences. That should set it apart from every other game that was ever made, because it's not that difficult to come up with something unique and have a twist on even existing ideas in just a couple of sentences. The prototype should be no frills whatsoever, all function. Doesn't matter if that transition fade is blocky. It doesn't matter if you think that gray color is boring. You just need to demonstrate that your game is playable and unique and has fun to be had. It needs to answer questions. Now, asking the right questions, that's its own art. Some of the most important ones, can the team execute? So you've got your engineers, your sound artists, your 2D artists, your 3D artists, and the prototype is a test run of everybody's pipeline and them all coming together. Also, let's figure out if the premise is fun, or is it viable? Like that example I mentioned earlier. Can we actually have a game where every pixel is a physics object? Because if you can't, then that game idea is dead in the water. So figure it out right away. And again, is there a weakness in the pipeline? You're going to find out, where that bottleneck is right away if you put everybody to work on a prototype. Now, like I said at the beginning, this is a communication tool. And one of the best things about communicating and conveying your ideas is acquiring feedback. So you want to determine who's going to be playing it, and you want to design it for that audience. If it's internal only, then you can do with even fewer frills than you imagine, because the developers themselves can fill in those blanks and use their imagination. Is it going to go out to more public? Then you may want to make sure it's slightly more polished so that they're not immediately turned off or distracted. And just remember that feedback is like the lifeblood of development. It invigorates everybody to hear what people think about their work. The assets that are used, like I've stressed, are going to be as low effort as possible. The art will be replaced. The sounds will be replaced. So use placeholder art. Use art that you grab from clip art. Sketch something real quick and put it in the game. That's what's most important, is putting it in, seeing how it looks, seeing how it's sized, its shape. Explore iconography instead of text. Writing text is really a arduous thing, and it needs to be spelled right, it has to be snappy, it needs to be concise. So instead, just work with icons as often as you can. Try to convey things with visuals, simple, and avoid complicated, statements and a lot of reading. Now, the last part's the best part, of course. You got to have fun doing it. If people are playing it more than they're developing it, that is such a good sign. That means your team has found the fun, and you need to find out why. Figure out what is fun and leverage it. Drill down on that. Strip away those other ideas that people aren't thinking about or talking about, and then expand on the good ones. Here's some really cool examples from some of my work. You can see I've got this little drawing of the enemy shot and how you're supposed to dodge it, and that's literally the entire concept for my game KITE. Is that you're running away and dodging at the same time. You can see here I've got some really simple assets without any textures. I've got some little enemies that are just about, purely programmer art for the most part in their first iterations, but they were enough to figure out what worked with the game and what I could do with the enemies. And then you can see their final versions, which are a lot nicer and more polished. This little game here, KITE Command, we're talking about the core concept only. It's a game that has 2 buttons, jump and shoot. So what can we do with those 2 buttons? Let's experiment. Let's find out. Let's use simple assets that we repeat and just program through that. Now on to the don'ts. Don't overproduce, as I've mentioned many times. Test mechanics, not volume of content. Every hour you're not making an asset means more time to make a quality one later. And if you invest a lot of time making quality assets early, expect them to still not be what you need in the end. Formats might change, the entire game premise might change, so you don't want to be wasteful. Don't rush it. It's a really small fraction of the dev cycle if you think about it. Typically less than 10%. So make sure that is just a wonderful time for everybody. Give it as much time as it needs. You can set, a tentative deadline for the end of the prototyping cycle, but you don't want to get into future dates where now things are happening before the prototype's actually done. So if you set your deadline for January and then you say also, let's launch the game 3 months after that and start preparing for that, then you're setting yourself up for a big problem. It's okay to give yourself a deadline, but you need to have room for that deadline to stretch out to. If you don't, subpar features could easily be rammed through. And if you have any failures now, they are going to be devastating later. And don't get attached. You need to be ready to scrap everything and restart from zero if it's not working. And that's where that feedback's going to come into play. You need people who are not so close to the work to give you sound, objective advice about how it's going, if it's fun, if they understand the design. If something isn't working, try a completely different approach. That's the beauty of prototyping. You can let go of all the work you were doing because it was meant to be replaced anyway, and try something brand new. It's really awesome if you're set up to do that, because you can be really agile and try a lot of different ideas really quickly. So when you make the prototype, don't delay any interaction that you're testing. So avoid extra barriers like logo screens or extra menus that don't matter for this particular prototype. For instance, most RPGs, you might be able to name your character. Well, everybody I know takes about 30 minutes to sit there and pick a name for their character. Avoid that. Just get people right into the action and start testing the game right away. So streamline users straight to what's being tested. So here, for some examples, we've got some overproduction going on. These were some, earlier KITE assets that I did. And you can see there's this huge level just coded in all kinds of different assets and objects, and just it's really an interesting level, but I built it too early in the process. I hadn't even finished the core gameplay loop. You can also see here there's cool little sets of icons that are just a pleasure to create. I love doing art like that, but it's not necessarily what you need to be doing earlier in the production cycle. You need to be testing core mechanics and grasping what the structure of your game is instead of just working on art and stuff like that. We've got some cinematics, also something you should do towards the end of the game, and then this really fancy explosion graphic that took like 20-30 hours to do, and those are all things that weren't necessary at the time that I made them. And these are just live and learn. I was learning a lot as I was making this game, and so I did have to do a little bit of extra experimentation and production to sort of focus my style and what I was capable of. But they're great examples of, again, what not to do during prototyping. So let's see one in action, huh? We're going to evaluate this early video of a KITE game, a KITE level. You can see that, there's definitely some low quality assets, like some of these enemies and maybe some of the textures, but there's also a lot of different stuff going on. I mean, look at all those different plants, look at all those different textures on the ground and tile sets, and I've got, as you can see, a user interface that's loaded up with different meters and resources that you're managing, you're leveling up. There's animated things, there's 5 or 6 different weapons already that you can switch between, and there's just so much going on. So what's good about it? Let's see, we'll start there. Well, even though there are a lot of resources, the interface is pretty minimal. It's not, suffocating you with information on all sides. There is definitely a fair amount of just experimental and placeholder art. Like I said, I was at the same time as developing the game, like teaching myself how to do quality art. So part of that was just going through those paces, but again, not something you should do during prototyping. But it is a really powerful game engine that I set up here as a sandbox. So I could do a lot of different cool experimental things in it. And that was a real big asset for, in the end, focusing the game design into what is most fun and most enjoyable. And so what's bad? There's too much experimentation. There's too many mechanics. There's not enough direction. This is one level. It's the only level I had for a long time. I should have gotten more of a vertical slice going, more of a full gameplay loop before I, doubled up on all these assets and all these mechanics and stuff like that. So a big overproduction of content, and I was learning, like I mentioned, while prototyping, and the gameplay loop is incomplete. So in the end, there's some good here, but this is a much better example, really, of what not to do. So, TLDR, prototyping. Let's summarize here. Why do we do it? We do it for communication, we do it to experiment, and we do it to find the fun or the value in playing. And we do it because it's inexpensive. You will start a burn, obviously, when prototyping begins, but it should not be a full burn because you're not going to be needing the same amount of art, sound, even engineering is going to be a little bit less, although that's probably where the majority of your time and money will go. So what is it? It's minimal, it's purposeful, so it's targeted, it's isolating, and it's a systems test. So again, it's got the least of every category of thing in it that it needs to just demonstrate the basic idea. It's going to be targeting, showing off one mechanic after the other. Once you get one figured out and you realize that it works, then you need to target the next one and you need to isolate it. And that might mean getting rid of the first one and just knowing that that's going to work later, or it could mean that they come in alongside each other, but you need to work on one at a time. And it's, like I said before, it's a systems test for not just, the engineering system, but the entire pipeline. All the players, all of the employees, all of the, all the horsepower you've got out there, you're going to find out what it's capable of and what the team can do. And so how do we do it? Well, We do it in an environment that the team is fluent in and is comfortable in. And we do it through iteration. We repeat, we trial and error, and we get feedback. We need to hear what people think about it. We need to hear what's good, what's bad, because the developers, we're too close to it. We do not know. I promise you this, no matter how objective you might think you are, it just takes one other person to sit down in front of your game for literally the blink of an eye to point out something just devastating that you completely overlooked. So you got to get eyeballs on the product immediately. And we do it with runway. We want people to not feel stressed about deadlines during this period. Otherwise, they won't be performing well, and they'll be ramming through failed features and not finding the fun and calling it a day anyways. So you can see here a couple of classics. We've got a screenshot from the prototype for Ocarina of Time on the Nintendo 64, and you see nice low poly flat textures. You know, it ain't that pretty, but it's going to be exactly what you need to demonstrate, hey, can we do this huge open world Zelda game? Can we, get players to be interested in going long distances without too much in between destinations? And then we have the Tamagotchi prototype, which is, if you don't know, it's a little, it used to be on a keychain, and you would have essentially virtual pets. And I mean, it's one of the most elegant designs for a game you've ever seen, and the prototype documentation is flawless. A really good example of how to do it if you ever want to check that out. So, a couple of questions you might ask yourself. They're critical questions that you might have at the end. There's a lot of emphasis put on finding the fun. How would we define that fun? How do you know when it's fun enough? And then considering the 4 dimensions of prototyping that we discussed, how can the appropriate level of each dimension be known for any given project? And those are questions that I'm not going to answer here, but everything you need to answer them is in this lecture. So I encourage you to think about that for the discussion afterwards. And just ending with a couple of cool examples. This is me doing some proper prototyping with KITE, showing pathing for enemies and a couple of simple mechanics. And that's on just a really simple background, low res, not a lot of effort, repeated assets, and that's the way it should be done. And then you can see some final screens here of the game in action with all the juice and the pixel art dialed up, and the lovely menus and all those transitions worked in there. And that, that's showing you the stark difference between the two prototyping and final version. So really hope you've enjoyed my presentation. It's something that I'm really passionate about, and I hope that you can find some enjoyment in the future if you ever get to work on a prototype or just curious about how things are made out there. So thanks so much for watching.